Hey everyone, and welcome to the third video in the OpenRocket tutorial series. My name is Aryanna Arcilla and I'm Launch Logistics Manager of Rutgers RPL. We'll be going over the start of making an L1 today. In this video we're going to make the nose cone, the body tube, and the motor tube. Then we're going to add a motor into the rocket. As this series goes on, I'm going to clarify some dimensions of certain parts of your L1. These values are given to you by us because these are parameters that need to stay the same for every Rutgers RPL rocket. And the reason for that is one of three reasons. One, you'll share this part with the rest of the team because it's too expensive or inconvenient for everyone to have on their own. Two, we'll give you the part, but everyone is getting the same one. So that's something like O-rings, which are small rubber rings, like you won't have to buy those. And three, we'll choose that dimension for a certain reason like stability, or maybe because it's very important for safety. Either way, just make sure that you're following the numbers I'm using, especially if you're an RPL member. However, this is still your personal rocket, and there are going to be certain parameters that are going to be up to you to decide. I'll let you know which ones those are, and I'll indicate it in text on the screen. Just one more thing before we start designing that I wanted to go over. Rutgers RPL is not responsible for any injuries, accidents, destruction, or fires of any kind caused by your L1 rocket, especially if it is caused by you not paying attention to instructions in the video or while doing the program in person with us. I'll say it again, your rocket stability needs to be 2 cal. It's not our fault if you are goofing off or making a mistake on launch day. We're also not responsible if you're following this video without being on Rutgers RPL, and if something goes wrong with your rocket as mentioned above. Thank you. Let's get started. Right now I have a fresh new org file open in OpenRocket. The first step is very crucial, and if you don't do it, you'll literally mess up all of your parts. Go to Edit, Preferences, and then open the Units tab. Right now mine is changed, but yours might be in centimeters. Go to Rocket Dimensions and then change to inches. Then hit Close. Most but not all of the values that I'm giving you will be in inches, so make sure that this step is done. Now we're going to add the first part of our rocket design, the nose cone. Remember that I had said in the first video that RPL shares nose cones, so everyone will have the same exact values for these parts. Whenever we want to add a new part to our rocket in OpenRocket, we're going to head over to the Add Component menu over here. This menu will have all the parts that we'll need for your L1, and all you have to do is fill out the numbers. So first click on nose cone. And the first tab that automatically pops up is the general tab. So just follow along with the properties that I'm switching. Ogive should be the nose cone shape that you have automatically, and we're going to keep it that way. Next, we're going to change the nose cone length to 23. And at this point, just double check and make sure that your units right here are in inches. If they're in centimeters, then that means that your units probably didn't save. So you want to go back to that step that I just talked about and change those units. Okay, now we're going to change the base diameter to 4. And you can see every time I hit enter, the picture in the view window will change with it. Okay, now we're going to change our wall thickness to 0.1. And lastly, our nose cone isn't made out of cardboard, it's made out of fiberglass. Then we're going to hit close. So now we finished adding our nose cone, but I did close out of the window. I'm going to show you how to open it up again because we're going to need to go back into it. So there's a couple ways you can do this. You can either double click on the part in the top left menu, or you can double click on the part in the view window. So now that we're back in the nose cone configuration, we're going to head over to the shoulder tab. What these parameters do is they make this slightly skinnier shelf off of the nose cone. In the picture I'm showing, the shoulder is the bottom part of the nose cone that's in blue, and it slides perfectly inside the body tube. We're going to change the diameter of the nose cone shoulder to 3.8. And the reason for that dimension is because it's slightly smaller than the inner diameter of the body tube. And then we're going to change the length to 3.75 inches. And the thickness to 0.1. So now you can see the view window, and it does kind of look like what's in the picture. There's this little square here, and remember that that little square gets slid into the body tube, and that's what helps compress the nose cone, the sides of the nose cone and the sides of the body tube together. Make sure your nose cone looks similar to mine right now because, like I said, everyone should have the same thing up to this point. So next we're going to start to make the body tube of the rocket. We're going to head back over to the Add New Component window, and we're going to select Body Tube. So now we're back in the General tab of the body tube configuration. And in the design manual on our Google Drive, you're going to see that some of the components are in green. What that means is it's customizable. So right now, we're going to have one customizable dimension for you for the body tube, and that's the body tube length. So just keep in mind that just because something is customizable, it doesn't mean that you get to choose it to be whatever you want. In this case, we're going to give you a range. So you can choose your body tube length to be any number from 20 to 30 inches. But there's a consideration that you should keep in mind for this. At some point, you're going to have to reach to the bottom of your rocket from the top and clip your parachute to the bottom. So this means that your body tube needs to be short enough for you to reach all the way down to the bottom. If you have long arms, this won't be much of a concern for you. If you're exactly 2 inches tall like me, you should consider making your body tube a shorter length. Remember that the body tube is definitely a factor in stability, and it's customizable. So if you're finding you can't get your rocket to be a stable 2 by the end of this series, this is definitely something that you can play around with later. To give you an idea, my body tube on my L1 was 23 inches, so that's what I'm going to change it to now. Okay, so that's it for customizable components in this entire video actually. So everything else you're gonna need to follow the numbers that I put in. So let's talk about outer diameter and inner diameter. Remember that a hollow cylinder has 2 diameters. It's the diameter on the outside with everything including the material thickness in it, and the diameter on the inside, which is essentially just empty space and it stops at the inner wall. So we have to put 2 diameters on our body tube. We have to put the outer diameter, which is going to be 4 inches, which is actually already put here. And the inner diameter is going to be 3.91. Okay, and your body tube is made out of cardboard, so we're going to leave that component material. You can see that also the wall thickness is kind of automatically filled out for us, and that value is fine. So we're going to close this. So next we'll be making the motor tube. Remember from the first video that this tube is here to hold your motor in place within the body tube. So we have to make sure that body tube is highlighted because as you can see, all of these buttons are grayed out. So in order to not gray them out, we're going to go over to body tube and highlight it. And now we're able to select these buttons. So we're going to go to inner tube under inner component. Okay, just to make sure that we know exactly what this inner tube is, we're just going to rename it at the top and call it motor tube. Okay? Okay, so in this next step, we're actually going to change the outer diameter and the inner diameter to millimeters. So the reason that we're going to do this is because we're given the motor diameters in millimeters, and the diameters in inches end up being decimals. It's much easier to enter in our values of 40 millimeters for the outer diameter and 38 millimeters for the inner diameter. So again, make sure these units are changed because if you don't, then this small tube over here is going to end up being 40 inches long, and we definitely don't want that. And now we're going to change the length of the tube to 7. And the reason that these values are set is because we give you your motor tube. And this motor tube that we're giving you will be made out of cardboard, so we're going to leave the component material. And hit close. Okay, so the last thing that we're going to do is add the motor to the L1. So I showed you how to take the motor out and put it back into the design in the last video. But when I go to flight configuration, there's nothing there. This is because we haven't told OpenRocket what motors we want to be using in our design. So right below the file menu, there's actually more tabs. So right now we're in the rocket design tab, but we're gonna go over to motors and configuration. So now we have to tell OpenRocket that we want our motor to be in our motor tube. So we're gonna go down to motor mounts and we're gonna check the motor tube. And now we're gonna go to new configuration. And we're gonna make sure that underneath the words motor tube, none is highlighted. That way we can replace that none with something. So now we're gonna go to select motor. And instead of just scrolling through all these names looking for what we want, we can just type in the motor that we'll be using for our simulation. So in the search, you're gonna type H148R. And you'll know it's the right one because it'll say the manufacturer is Aerotech. So tap it once. And RPL members should keep in mind that although we selected this motor to be in our simulation, this isn't the motor that we're actually using. The one that we're actually using is also by Aerotech, but it's the H130W. If you try to search this one, you're not gonna find it in OpenRocket's database. But this motor that we're using to simulate the H148R, it's very similar to the H130W. So we're gonna use this one for our simulation data. So there's one more thing that we have to do, and that's to change the ejection charge delay. Right now it's at 0, but we're gonna change it to 14. And then hit OK. Okay, so we've now finished adding some crucial parts to the rocket. My stability is currently at negative 3.83 cal, but that's okay for now because all of these parameters are really set in stone and you're really not gonna be able to change much of it except for the body tube length. Plus, we're missing a lot of parts and the fins are gonna get the stability to where it needs to be. So that is gonna be covered in the next video. Thank you for watching.
Subscribe to our channel to keep up with all our latest content and launches. For more of Rutgers RPL, check out our social media links, as well as our website at www.rutgersrpl.com. Join us today.